Hello everyone, welcome back. So today's topic is geometric progression. I'm going to give you some special tricks to solve the questions. So watch the video till end. Let's continue. So a sequence is said to be a geometric progression or GP if the ratio of any term to its preceding term is same throughout. Now what does it mean? So let's say if I am taking one simple sequence, okay? So 2, 4, 8, 16 and so on. Now if you see here, if I'll just take the ratio of 4 and 2, this is 2. Here also 8 divided by 4, that gives me 2. 16 divided by 8, that gives me 2. So the ratio is constant, right? So this constant ratio is called R. Okay, R is 2 for this example. Alright, and I can say that this sequence is in GP, geometric progression. Alright, one more example I can take. Let's say 25, then 5, 1, 1 over 5 and so on. Right. So this is also in GP because the constant ratio is 1 over 5. See, you have to take the next term and the preceding term ratio. Okay, like this. Okay. So in general, I can say that if the first term, if we denote it by A, common ratio denoted by R, then the geometric progression is written as AR, AR square, AR cube and so on. So this is the general form. Okay. And now if I want to find the nth term of the GP, I can give nth term as A R raised to n minus 1. If you see here, see the second term, it is AR, right? Second term, so it is 2 minus 1, which is this. Okay. Third term is AR square, like that. So the general term or nth term is given as Tn A R raised to n minus 1. Alright. Okay. Now I have to find the seventh term of this GP. Okay. So we just learned that nth term is what? So nth term is given as Tn equals A raised to R raised to n minus 1. Okay. Now we'll find what is A here. So the first term is A. This is 1. And the common ratio. So root 3 over 1. So it is just root 3. Okay. So R is root 3. Now as we want to find the seventh term, I'll write T7 equals, first of all we'll write the formula. So R raised to 7 minus 1. And now we'll substitute the values. So A is 1, R equals square root of 3 to the power 6. Now understand this. See, square root of 3 to the power 2 is how much? Yes, it is 3. And when I say square root of 3 to the power 2 and to the power 3, because here it is power 6, so 6 is 3 times 2, right? I can apply the exponent rules. So this is 3 square and 3 square is, 3 cube and 3 cube is 27. So I can write this as 27. So the seventh term of the GP is 27. Alright. Now here we have to find next two terms of this series. Okay. Again the nth term is nothing but Tn equals to A R raised to n minus 1. Now here it is important to understand the common ratio. So we'll understand it. The first term is square root 3 plus 1. Now to find the R, I have to take the next term, which is 1, and the preceding term ratio. Okay, so this is the R value. Now you know that, see, we can't write this in irrational denominator, we can't express in irrational form. So what I'll do, I'll just multiply with its conjugate. So I'll just get this as root 3 minus 1 upon this. So on simplifying this, I'll get root 3 minus 1 upon This is a minus b, a plus b form. That gives me root 3 square minus 1, and on simplifying, root 3 minus 1 upon 3 minus 1, which is 2. So I can also say that the common ratio is square root of 3 minus 1 upon 2. Now it is very easy to get the next two terms. Okay. So I have to simply multiply the next term by the ratio. This. Okay. So now the, see, first, second and third terms are given. So I'll say fourth term will be root 3 minus 1 upon 2 and this r value. So r value is root 3 minus 1 upon 2. So this gives me root 3 minus 1 whole square upon 2. And the fifth term. So we have to multiply the fourth term by this common ratio. Okay, so minus 1 square upon 2 into root 3 minus 1 upon 2. This gives me root 3 minus 1 to the power 3 upon 8. So these are the next two terms. Okay, this and this. Alright, I hope you understood this one also. Great. Alright, now the fourth and the seventh terms of GP are 1 over 18 and minus 1 upon 486. Then we have to find GP. It is very simple. You have to think about the nth term. Now remember that nth term is Tn equals a r to the power n minus 1. Okay. Now the fourth and the seventh terms are given. So I'll write this. So T4 is given, which is nothing but a r raised to 4 minus 1, that gives me 3. And this is nothing but 1 over 18. This is given. Okay. Same way, seventh term is given. So T7 equals a to the power 6, because 7 minus 1, and this is given as minus 1 upon 486. Okay. Now what do we have to do? We have to take this ratio. So I'll take the ratio of T4 to T7 is equals to 1 over 18 upon minus 1 over 486. And now if I substitute the values, what do we get? A r power 3 upon a r power 6 equals. Now, do you remember the ratio a upon b whole upon c upon d? So this is nothing but a upon b into c, and d goes up, right? So we'll apply that over here. And minus sign I'll put in the numerator, because we learned that standard form, correct? So I'll put minus 486 and 1 goes up. So 486 here upon 18. And now on simplifying this, what I'll get? A will get cancelled out. R cube upon r raised to 6. So I'll get 1 upon r cube is equals to minus 27. And now I can say that r cube equals to minus 1 upon 27 and r equals to minus 1 upon 3. So I got the common ratio. Now I can find the value of a. So we'll find the value of a using it. So I have a into minus 1 upon 3 cube equals 1 upon 18. So a is equals to, on simplifying this is minus 1 upon 27, that goes on the other side, and that gives me minus 3 upon 2. So a is minus 3 upon 2. Now we got the first term and the common ratio. So I can say the GP. So GP is minus 3 upon 2. Second term, if I multiply this 2, I'll get plus 1 upon 2. The next term is a r square. So I'll get minus 1 upon 6. Fourth term is 1 upon 18 and so on. So this is the GP. Now the fourth term, seventh term and the last term of the GP are 10, 80 and 2560 respectively. We have to find the first term, common ratio and number of terms. So remember Tn equals to A r raised to n minus 1. So we'll use it. So T4 equals to A r cube, which is 10. T7 A r raised to 6. This is given as 80. And T nth term, last term is given, but we don't know which is the nth term. So we'll write this A r raised to n minus 1, which is equals to 2560. Now we'll take the ratio of T4 and T7 to find the value of so I'll make T7 to T4 so that it will be easy for us, okay, to find it. 80 over 10 and this gives me A r raised to 6 over A r raised to 3 and this gives me 8 is equals to r cube. So we can say that r equals to 2. On putting this in the first over here, we'll get A equals to how much? 10 over 8, which is 5 over 4, right? So we got the first term and the common ratio. Now we have to find how many terms are there. So now we'll put this value over here, okay, in Tn formula. So Tn is equals to 2560 equals, now A is 5 over 4 into 2 to the power n minus 1. Now on simplifying this, what I can say, 2 to the power n minus 1 equals to 4.5 into 2560. And when I simplify, this gives me if we divide by 5 and then multiply it by 4, this gives me 2048 and that is nothing but n power minus 1 2 to the power 11. So when the bases are same, exponents are also same. So I can say n minus 1 equals 11. So n equals to 12. So there are 12 terms here in GP. So we found all three values. R equals to 8 equals 5 over 4. N equals 12. Okay. Now this questions involves logarithms also. So we learned the product rule of log. Okay. So log m into n equals to log m plus log n. And we learned the power rule. Log m to the power k equals to k log m. Here we need these rules. Okay. Okay. Now pth, qth and rth terms are given and they are A, B, C. Now here R and A are used for this terms, okay, values. So we will say that the Tn equals to, instead of small a, I'll take capital A, r raised to n minus 1. We'll take this as the general term, okay, and now we'll use it here. So pth term, so what I can say, Tp equals A and that is equals to A r raised to p minus 1, okay. Tq equals to B equals to A r and it is q minus 1 and T r equals C equals A r small r minus 1. Okay. Now this question only give me hint that I have to take a raised to q minus r by applying the product power rule of the logarithms. Okay, so what I'll do, I'll just write this as, first of all I'll find a to the power q minus r. Now as this is the plus sign with logarithms, so I have to apply the product rule also. So now what I'll do, into b to the power r minus p, okay, and c to the power p plus q. So I hope you understood that we applied the product and the power rule of the logarithms to think what we have to do so. Okay. Now if I substitute the values of a, b, c which we got here, so I'll put that a capital R p minus 1 into q minus r. I am applying the exponent rules as well, into a, this is raised to, okay, a r raised to q minus 1 whole raised to r minus p, and c is nothing but a r minus 1 whole raised to p plus q. And now we have to simplify this. So if I simplify, what I'll get, a to the power q minus r for this. Then here a to the power r minus p. So I'll just add the exponents and I'll get r plus r minus p and plus p plus q. Now r to the power. So r to the power pq, then minus pr, then minus q, minus minus plus r. Now I'll add the other. So qr minus pq minus r plus p and plus pr plus rq or qr minus p and minus q. And when we simplify, I'll get a to the power 0. I'm writing it here. A to the power 0, r to the power 0. This gives me 1. Now I am taking log both the sides and I apply the product rule and the quotient rule. Okay. So what I'll get that here. Okay. See this value. Let me write it here so that you can understand. I got that a q minus r into b r minus p into c r plus q, this is equals to 1. Now I take log both side. Okay. So what do we get? And I am applying the product rule as well. So I'll get q minus r into log a plus r minus p log b plus p plus q log c equals log 1, which is 0. Hence proved. Okay. Now we want to find the sum of n terms of the GP. Now for example, the GP is, let's say, 1, 2, 4, 8, 16 and so on. Okay. And now when I say sum of n terms means I am adding those. Okay. Like this. And this will go on. Okay. This will go on. So this is sum of nth term and n terms of the GP. Alright. Now here some different cases are there. And if you don't remember the cases, if you apply simply this formula, it will work for all. Okay. Remember that. If you don't remember which are the cases and how to apply, it's perfectly fine. Only you have to remember this formula. Okay. Now we'll understand the cases. Now when r equals to 1, that means what? let's say 2 plus 2 plus 2 plus 2. See this GP 2 into 1, 2 into 1. So every time the constant is 1. So this is in GP. Okay. And when I want to add them, so I can say Sn is equals to, these are nth term, n terms here. So I can say that it is n times 2, or I can say it is 2n. Right. Now when r is smaller, I can use this formula, which is 1 minus r raised to n in the bracket. Okay. And when r is greater 1, I can use this formula. And again, doesn't matter if you don't remember. Okay. You can apply any of, this formula, and you can get the same answer. Just for your information, sum of the infinite terms in GP is given as a upon 1 minus r. Okay, if these terms are not ending at n, okay, they are going on infinite series, and this r is less than 1, okay, then we can apply this formula. Alright, let's understand with the example. Now GP is given and we have to find the sum of these 8 terms. So let's list down what is given to us. First term, a equals to 0.3. The ratio, if I see r is equals to, here if I multiply it by 0.1, I'll get the next term, correct? So r is 0.1. And now I can apply the sum, this formula. Now here r is less than 0.1. Okay. Now I told you, see, if you don't remember this formula, okay, the second one, for r less than 0. So which is fine. You should know only one formula, which is this formula. And I'll show you with this formula, we'll get the same answer, okay. So 8th term. So S8 is equals to, A is 0.3 into 0.1 to the power 0.1 minus 1. And on simplifying this, so what do we get? 0.3 into 0.1 to the power 8, I can write as 1 over 10 to the power 8 minus 1 upon, this gives me minus 0.9. And now I can simplify this. See, I can take the minus sign common and I can cancel out both the minus sign, and finally when I cancel 0.3 and 0.9, I get 3. So my answer is 1 upon 3 into, now you have to flip these two numbers, okay, because we are taking minus sign out. So 1 minus 1 upon 10 to the power 8. So this is the sum of the first 8 terms in the GP. A boy spends rupees 10 on the first day, rupees 20 on the second day, 40 on the third day, and so on. Okay. So how much in all he spent in 12 days? So it is clearly stated that this is in GP, right? So I can say that the first term is 10. Now the common ratio r is double every time, so it is 2. And we have to find S12. So S12 equals to, first of all write the formula, r to the power n minus 1 upon r minus 1. If I, on substituting the values, 10 into 2 to the power 12 minus 1 upon 2 minus 1, this gives me 10 into, this is 2 minus 1, which is 1. So I can simply say that it is 4096 minus 1. And on simplifying, I'll get 4095. So 4950. This is the total amount he spent in 12 days. Right? Now, in this question, the ratio between the sum of first 3 terms and the first 6 terms are given. And we have to find the common ratio. So, sum of first 3 terms is equals to a r raised to 3 minus 1 upon r minus 1, and first 6 terms as 6 equals a r power 6 minus 1 upon r minus 1. And now the ratio of these two are given. So we'll take the ratio as 3 to as 6, and when I write this, what do we get? A r raised to 3 minus 1 upon r minus 1, a r raised to 6 minus 1 upon r minus 1, and we can cancel out r minus 1 and a from here, and by simplifying, now this ratio is given as 125 upon 152. So what I'll get here is r cube minus 1 upon r power 6 minus 1. Okay, now I can write this as 125 upon 152 equals. Now the denominator I can factorize using a square minus b square identity. Okay, keep the numerator same. Now this is what? R cube square minus 1 square. So I'll say r cube square minus 1 square. And by applying a square minus b square identity, I can write this as r cube minus 1 upon r cube minus 1 into r cube plus 1. So I can cancel out r cube minus 1 now, and now it is left with this 1 upon r cube plus 1. Now flip both the ratios, means take the reciprocal of both of them. So 152 upon 125 equals r cube plus 1. Now I can simplify this. So r cube equals to 152 upon 125 minus 1. When I simplify this, I'll get 152 minus 125 upon 125. And this gives me 27, right? Upon 125. So r is equals to, by taking the cube root, it gives me 3 upon 5. Okay. Now sum of three numbers in GP is 39 upon 10, and the product is 1. So find the numbers. Now remember a trick. Okay. So when 3 or more terms, let's say 3 terms. So you can take the 3 terms are a upon r, a and ar. 4 terms, then a upon r square, ar, a and ar square, like that. Okay. So here 3 terms are given. So let the terms are a upon r, a and ar. Okay. Now they said that sum is this and the product is this. So first of all I write the product. So product. So if I multiply a upon r into a into ar. So what do we get? This is equals to 1. We can cancel out a and I'll get a cube is equals to 1. So a is equals to 1. So the first, this term would be 1. Now, so the terms will be now 1 upon r, then 1, and let me write it here. So the terms are 1 upon r, 1 and r. Okay. Now they are saying that sum of this is 39 upon 10. So I'll write this as 1 upon r plus 1 plus r is equals to 39 upon 10. Now don't afraid. Okay. They take the LCM and step by step simplify it. So if I'll take the LCM, what I'll get? 1 plus r square upon r is equals to 39 upon 10. Now I'll simplify them here. I'll cross multiply and I can write this as 10 1 plus r square equals to 39r. Now on simplifying this, so what do we get? 10 plus 10r plus 10r square equals 39r. And now we'll bring everything on the left hand side. So, and I'll rearrange. So 10r square minus 10r, it is plus 10r minus 39r. So I can write this as minus 29r plus 10 equals 0. Now I can solve this using the splitting the middle term method. Now I hope you know that method, and if you don't know, I'm going to give the link in the description box so you can watch that video. Okay. So 10 times 10 is 100 and 25 times 4 is 100. So I can say that 10r square minus 25r minus 4r plus 10 equals 0, and grouping this and factorizing. So 5r common, I'll get 5r, sorry, 2r minus 5 minus 2 common, 2r minus 5 equals 0. So 2r minus 5 equals 0. 0 product rule we have to apply. So 5r minus 2 equals 0. So it is r equals to 5 upon 2 or r equals to 2 upon 5. Now when r equals to 5 upon 2, the ratios are, this terms are, okay. What it will be? 2 upon 5, 1 and 5 upon 2. When it is 2 upon 5, then it is 5 upon 2, 1 and 2 upon 5. So these are the numbers, okay. See, they are same but just the ascending and descending order, okay, just like that. So this is very simple and easy topic, okay. It is very scoring topic, and this geometric progression can be asked in competency competitive exams also, okay. So these are some practice questions, solve them. If you have any doubt, or then you can ask me in comment box, I'll surely reply to you. Also, you can share this video to your friends, and please like and subscribe the channel. Thank you for watching.